we find subnet masks in many shapes and sizes. I'm not going to say all shapes and sizes because effectively there's only so many that are practical. But let's say we were tasked with enabling OSPF for any interface in this subnet. Now, we're only going to have one interface in a given subnet on a router. But let's say the interface host portion changed. Let's say we maintained one at 10.1.98, but someone decided I really need to change that to be maybe the first IP address in the subnet. I want my network statements to be immune to people changing values such as that, or at least there might be a scenario where I might desire that. So we want to be able to convert any subnet mask to any wildcard mask. How do we do that? We subtract the subnet mask that is to be converted from all 255s. It's a powerful technique commonly used in Cisco. And if we apply that here, we get that wildcard mask, .1.255, and then I could say the following. I could go into my OSPF routing process. I could put in the subnet ID. Now, I do want to put in the subnet ID, and if you're really good with subnetting, you might look at that and go, that subnet might be a little challenging for you. But we do the ANDing process of the subnet mask to the IP address, and I'll just bypass that because this is not a subnetting discussion. But this would be the appropriate network statement, but we're talking OSPF, right? So there's something to add to this. We add whatever area it might be, and away we go. And now we have successfully converted the subnet mask of an interface, we might see that in our topology, to a wildcard mask. Do this in the exam when necessary. Do it in the real world only if really pinned down to it. This would not be the recommended approach, but it is important to know the technique. To know this technique, we want to make sure that we can do it repeatedly. So let's again take the given subnet mask, convert it to a wildcard mask, subtract from all 255s the subnet mask that is to be converted. You will get that wildcard mask. And you'll do a sanity check, hopefully, and just make sure that all your octets are of the legitimate value or a legitimate value, which is something that is less than a power of 2. These are the legitimate values that you will find in a wildcard mask unless you're doing something really complicated like finding odds and evens. These are the wildcard masks that you'll find in access control lists, in network statements, and it's good to validate that all your octets fall within one of these very specific values. So your network command would then look something like this. Go into your OSPF networks, OSPF configuration mode, and it looks like .64 is the subnet ID. I'm doing ANDing in my head. I don't expect you to do that. We're going to focus on wildcard masking here. But this would represent anything from .64 through 127, which is inclusive of that IP address. That would be important. So being good with wildcard masks takes a little bit of practice, but once you get the techniques down, well, you're going to be able to do wild things.